Hello, here we will demonstrate the use of the 3D photogrammetry tools in SSMC's Sphere Viewer application. The Sphere Viewer application runs in a web browser and allows the user to view 360-degree panoramic images and extract three-dimensional location information for features visible in any pair of images. The images and data shown in this demonstration were collected using SSMC's mobile imaging system and are hosted on a secure website. SSMC's mobile imaging system can collect 360-degree panoramic images at 30-foot intervals while traveling at posted speeds. With each image, sensors on the mobile mapping vehicle capture the camera's location, elevation, and heading. The viewer's photogrammetry tools use this three-dimensional data to locate and measure features visible in any pair of images. Let's say we need to collect information about street signs along the roadway we see here. We will use SSMC's viewer application to identify this sign, locate the base of the signpost, find the elevation of the bottom of the sign, measure the height and width of the sign, and measure the distance from the ground to the bottom of the sign. First, we will use the viewer to determine the coordinates and elevation of the base of the signpost. We begin by choosing the point measurement tool. This tool prompts us to pinpoint a feature visible in image A on the left and in image B on the right. Starting from image A, we will fix the viewer reticle to the image pixel where we see the signpost meet the ground. We click Select Point Image A, and the application records the camera location and the reticle position from image A. Next, we look at image B and again fix the reticle to the image pixel where we see the base of the signpost. We click Select Point Image B, and the application now records the camera location and the reticle position from image B. The number to the right of the Select Point Image B button shows us the amount of error between the base of the signpost's position in image A and its position in image B. The smaller the error, the more accurate the position of the base of the signpost. We click the Select Point Image B button, and the application calculates the three-dimensional position and displays that point in the viewer. Here we can see the coordinates of the base of the signpost, and the ground elevation at those coordinates is approximately 42 feet. If we are not satisfied with these results, we can click the Clear button and start over from the beginning. When we are satisfied with the results, we click the Save button. The application saves the coordinates and elevation of the base of the signpost as a point, and prompts us to enter the description, Hospital Signpost. Now we will find the coordinates and elevation of the bottom of the sign. Again, we pinpoint the bottom of the sign in two images using the same procedure we used to locate and elevate the base of the signpost. We fix the reticle in image A to the bottom of the sign and click Select Point Image A. Then we fix the reticle in image B to the bottom of the sign and click Select Point Image B. The viewer displays the coordinates of the bottom of the sign, and the elevation at those coordinates is approximately 51 feet. When we are satisfied with the results, we click Save and enter a description for the point as Hospital Sign Elevation. Now we need to determine the height and width dimensions of the sign. To find linear measurements, we will choose the Line Measurement tool from the toolbar. The line measurement tool will prompt us to pinpoint one location visible in both image A and in image B, and then pinpoint a second location visible in both images. We will use the viewer to locate two corners on each side of the sign, and the distance between those 2 points will give us that dimension. First, we will fix image A's viewer reticle at the bottom left corner of the sign and click Select Point 1 Image A. Then we will fix the reticle in image B to the same corner and click Select Point 1 Image B. Next, we'll fix the reticle in image A at the top left corner of the sign and click Select Point 2 Image A. Then we will fix the reticle in image B to the top left corner of the sign and click Select Point 2 Image B. The application calculates the coordinates of point 1 and point 2, and then calculates the distance between those points to give us a line that measures the height of the left side of the sign. As with the point, the application displays the line in the viewer and reports the length as 2.5 feet. If we are happy with these results, we can click the Save button, and the application saves the measurement as a line and prompts us to enter a description. We will call this line Hospital Sign Height. Next, we'll measure the sign's width. Starting again with the bottom left corner of the sign, we'll fix the reticle in image A to that location and select 0.1 image A. Then we'll find the same corner in image B and select 0.1 image B. Then we'll find the bottom right corner of the sign in image A, click Select 0.2 image A, and then find the bottom right corner of the sign in image B and click Select 0.2 image B. Again, the viewer shows us the line was measured at 2.5 feet. We will save these results and call this line Hospital Sign Width. Now we will measure the distance from the base of the signpost to the bottom of the sign in the same way we measured the sign height. First, we'll find the base of the signpost in image A and in image B. Then we will find the bottom of the sign in image A and in image B. Technically, we have already created points at the base of the signpost and at the bottom of the sign. However, we would like to have the height of the signpost as a separate feature with its own description. Having made our selections, we review the results, and here we see that the height of the signpost reported as approximately 9 feet. We save this measurement as a line feature, entering the description, height of hospital signpost. Now we can view our measurements saved as features in a table by clicking the database icon here. We can select the plan view to review our features in 2 dimensions with background data. And we can use the 3D view to review our measurements in 3 dimensions. We can also extract a fixed perspective image from our viewer by clicking this Extract button. This will give us a JPEG of what we see in this view. Any graphics displayed in the viewer are included in the exported image. If we want an image without any graphics, we click the Clear button and then click Extract. Here we have an image file for our hospital sign. Finally, we can export our measurements and their descriptions by clicking the Export button in the Saved Measurements dialog. Point features and line features are exported as separate files to a GeoJSON string or a CSV file. The GeoJSON strings in the CSV files can be loaded into a GIS database. The CSV file can be opened directly in Excel. Thank you for watching this demonstration of SSMC's Sphere Viewer and the 3D photogrammetry tools.